Hello students, today we are going to discuss the fourth numerical of indeterminacy of beams. Question is written as, find the indeterminacy of following beam for general loading and extensible member. It means that we need to calculate here the total indeterminacy as per the general loading and for the extensible or flexible member. Okay. Now we know that for the total indeterminacy, it will be the sum of static indeterminacy plus kinematic indeterminacy. Now for the calculation of total static indeterminacy, we need to calculate the external static indeterminacy plus internal static indeterminacy. Now for the calculation of external static indeterminacy, we know the formula, that is R minus S. Now R will be the total number of support reactions here and S will be the number of equilibrium condition. Now for general loading, we know that the total number of equilibrium condition will be 3, that is summation of vertical forces equals to 0, horizontal forces equals to 0 and summation of moment about any point equals to 0. Now the number of reaction which will be present in this beam will be, for general loading there will be 3 reactions at support A. Okay, at support A there will be 3 reactions, that is vertical, horizontal and moment. Okay, now at support B and C there will only be one reaction, that is vertical reaction, because B and C are simple supports. So the total number of reaction will be 3 at support A, 1 at support B and 1 at support C. So the total sum will be equals to what? 5. Now if we want to calculate the external static indeterminacy, we need to put the value of R and S here. So the total external static indeterminacy will be equals to 2. That will be the external static indeterminacy value. Now we know that if we know the value of all the external reactions in a beam, then we can easily determine the internal reactive forces. Okay, so the total internal static indeterminacy will be equals to 0. But in this beam there will be one internal hinge which is present in between B and C. Okay, now we need to subtract that value from the internal hinge. So which value will be subtracted? The number of members connecting at that internal hinge minus 1 needs to be subtracted from the internal static indeterminacy. At this internal hinge there will be 2 members connecting at this internal hinge, so we need to subtract here 2 minus 1. Okay, now what will be the internal static indeterminacy? It will be equals to minus 1. Now we have the value of internal static indeterminacy as well as the external static indeterminacy. Now if we want to calculate the total static indeterminacy, then it will be the sum of what? It will be the sum of external static indeterminacy plus internal static indeterminacy. Now just put both these values here, that is 2 minus 1, then it will be equals to 1. That will be the total static indeterminacy of this beam. Now if we want to calculate the kinematic indeterminacy here, then for the kinematic indeterminacy calculation, we need to find the number of possible moment at each and every joint. Now we know that at fixed support there will be no degree of freedom, so the degree of freedom value will be equals to 0. Now for extensible member at simple supports there will be two types of possible movement, one is horizontal displacement and one is rotation. Similarly at joint C there will be one horizontal displacement and one rotation, and at free support D there will be horizontal displacement, vertical displacement as well as rotation. So the total possible movements will be 0 at A, 2 at B, 2 at C and 3 at D. Now if we do the sum of all these values, then it will be equals to 3 plus 2 plus 2, it will be equals to 7. Now if we want to calculate the total indeterminacy, then it will be the sum of static plus kinematic indeterminacy. Now just put the values of both the static indeterminacy as well as kinematic indeterminacy here, then it will be the value as 8. So the total indeterminacy of this beam will be equals to 8. 1 is static indeterminacy and 7 is the kinematic indeterminacy. That is all about this question. We had calculated the total indeterminacy equals to 8. Thank you very much, students.